Shalom to you. So to solve this problem on bearing, we want to first of all draw a picture. So it's between a ship and a buoy. A buoy is most of the time anchored, so that is just floating around, but it's like a reference to the sailors. So the first point is 44-degree course. So let's say this is P1, the first point. And this first point has, of course, north, south, east, west. And the course is 44, so which is close to 45 in the middle here. And let's say it's right here at that point. And this is 44 degrees. Its size, the buoy is at bearing 134. So 134 and 90 is in the second quadrant. So about there. So it has so the buoy B is over here. And this is the whole length. I mean the angle is 134 degrees. And so if we subtract 134 degrees, if we subtract 134 minus 44, this is 90. So this angle here is 90. That means we have a 90-degree angle right there. So the bearing and the line of sight to the anchor is 90 degrees. So here, let's make this point B. Let's take this point B. So it's PB, point 2, I mean. So, and it's going to have its own north, south, east, west also. And the bearing is 168. So it's still in the second quadrant, but a little closer to so this is close to the 180 line. So this is 168. All right, so now let's see what is left off of 180. 180 minus 168, that's 12. So this little angle here will be 12. Right? To complete it, 180. All right, so if we have the distance from this is 15 kilometers. So this is 15 kilometers, the distance from the first P1 to P2 where the ship had traveled. And now we have 90 degrees, this is the first, D1, the distance, the first one, and then D2. From the first place, P1 to the buoy, and then P2 to the buoy. Then we need an acute angle though. This is 12, but we need this whole angle here. Well, if we look closely, we will see that the north-south pole and the north-south line, they are parallel. If they are parallel, so that means this line is a transversal. So this is 44, that means this is 44 as well. 44 degrees. Therefore, if we add both 44 and 12, we get 56 degrees. So now we have one acute angle to work with. So to find distance 1 is opposite. This angle is opposite. The hypotenuse is D2, and then the adjacent is 15. So if you reconsult the SOHCAHTOA, so we have opposite and adjacent, because we cannot use the hypotenuse and opposite because they are both variables. So opposite and adjacent, so that's TOA. So then we're going to do tan of the angle 56 is is equal to opposite, which is D1, over the adjacent, which is 15. If we cross multiply, if we like, we can put 1 here if we want. So this is going to be D1 equals 15 times tan 56. So plug it into our calculator. So we have 15 times tan 56. Good to check to make sure calculator is in degree mode, and I have been working in degrees. So 22.2. 22.2. And it's kilometer. Okay, so we do look at the other one. So this is hypotenuse and adjacent. Hypotenuse and adjacent is car. So we're going to use car. So cosine of angle 56 equals adjacent. Now it's 15 over the hypotenuse, which is D2. Again, if we cross multiply this, we can, put this over 1 if we want. If we cross multiply this, we are going to have 15 equals D2 times cosine 56. So we're going to divide both sides by cosine 56. So 15 over cosine 56 equals D2. And again, we plug it into our calculator. So I'll use fraction for y. So I have 15 divided by cosine 56. And that's 26.8. And that's the two distances. Okay, good problem.